Hello everyone, this is part 3 of RC and RLC circuits. We left off the last video talking about this page of notes which explains how to deal with the RLC circuit. Here's our two main equations, and we're always going to start with, as opposed to the RC circuit where we found the charge, for the RLC circuit, we're first going to want to find the current. So we're always going to start with this equation. One thing to note is that I is the variable, is the dependent variable, t independent. So this turns out to be a second order, I double prime plus I prime I, second order linear differential equation with constant coefficients because L, R, and C are constants. One thing to note is that E of t here, it's not E of t, it's E prime of t. So if E of t is a constant, then like 50 or whatever, 50 volts, whatever, E prime of t is going to be 0, so therefore this would be homogeneous because it would be equal to 0. So then we just simply have a second order linear homogeneous differential equation with constant coefficients. That's easy to solve. And if the E of t is a function of t, then E prime of t will either be a function of t or maybe a constant, but it's going to make it a non-homogeneous. And if it is non-homogeneous, then we have to pay attention to the fact that the solution is composed of two parts: the complementary function, which is the solution to the homogeneous, and the particular, which is the solution to the non-homogeneous. So we have two more examples. First one is going to be a situation where it turns out to be homogeneous, and second one, a situation where it's non-homogeneous. But a very important thing to note here is something that we wouldn't really expect. It's concerning initial conditions. We're only going to know the initial conditions for the charge and the current, so Q of 0 and I of 0. If we have to solve our equation for the current, we're going to need to find I prime of 0. And so we consider, to find I prime of 0, consider our main equation again, but recall that it came from taking the derivative of LQ double prime, R plus RQ prime plus 1 over C times Q equaling E of t. Because there we'd get LQ triple prime, which is I double prime, and RQ double prime, which is I prime, and Q prime, which is I. So if we take that equation now and we substitute I prime for Q double prime, I for Q prime, and we leave the Q, and then evaluate that, so that's true because Q double prime is I prime and Q prime is I. If we consider that equation and we let t equaling 0, then we have a new equation that will allow us to solve for I prime of 0, because we will be given R, L, and C, and the initial conditions I of 0 and Q of 0. Just one other thing we'll have to remember is to evaluate the electromotive force, E of t, at 0 as well. Excuse me. So after we find the general solution, we're going to have to find I prime of 0 by this equation, and then we will be able to use the initial conditions I of 0 and I prime of 0 to finally find the solution for I of t. Okay, so two more examples. Finish up this section. Hopefully we can get through it within this one video. And so the first one, find the current, and that's all we want to do. So we're going to start with, once again, the L double prime Li double prime, that is, plus Ri prime, plus 1 over C times I equaling E prime of t. So one thing to note right away before we even start substituting the RC's and L's in is that E of t in this case was 120, so that's a given right here. So therefore E prime of t is going to be 0. So now we can substitute. So L was 2, so 2I double prime plus R60 I prime plus 1 over C 0.004 times I is equal to the E prime of t, which again we found to be equal to 0. So let's just be careful, not make any mistakes. 2I double prime plus 60I prime plus 1 over 0.004 is 250I equals 0. And to make things simpler, since all the coefficients are divisible by 2, let's divide out the 2. So I have I double prime plus 30I prime plus 125I oops. So plus 125I is 0, and that's a second order homogeneous differential equation with constant coefficients. So we form the characteristic equation, be r squared plus 30r plus 125 is 0. This is actually factorable. R and R, if we use a plus 5 and a plus 25, it works. So R plus 5 is 0, R plus 25 is 0, so R is negative 5, R is negative 25. So therefore, since these roots are real and distinct, the equation for I will be, I of t we could say if you like, is going to be C1 e to the negative 5t plus C2 e to the negative 25t. But in order to solve for those constants, we need the initial conditions, and we only have Q of 0 and I of 0 as the initial conditions. To solve for constants C1 and C2, we're going to need I of 0, which we have, but we're also going to need I prime of 0. Actually, let's find I prime of t first. That's going to be negative 5C1 e to the negative 5t minus 25C2 e to the negative 25t. Okay, and now let's say we need I prime of 0. Okay, so if you recall from the previous page, that was the equation that we had at the bottom here, and these I'll give you on the cheat sheet for your exam. And so the equation to find I prime of 0 is Li prime of 0 plus Ri of 0 plus 1 over C times Q of 0 is E of 0. Okay, and notice that's E of 0, not E prime of 0. So let's substitute. We know L is 2. I prime of 0 is what we're looking for. The R was 60. I of 0 was known to be 0. from our initial condition, plus 1 over c. C was 0.004, but q of 0 also known to be 0 from the initial condition. And that's equal to E of 0. E of 0 is plugging a 0 into E of t. E of t is 120, so E of 0 is 120. So it turns out the I of 0 and Q of 0 both being 0 cause these terms to go to 0. And so we get that 2I prime of 0 is 120. And so I prime of 0 is 60. Okay, so now with the initial conditions, first initial condition, we'll take I of 0, which was given to be 0, is now equal to, okay, so go back up to the I of t. 0 equals C1 plus C2. And for the initial condition I prime of 0 that we just found to be 60, then we have 60 equals, okay, so we're going to I prime of t, the negative 5c1 minus 25c2, and we're going to solve this system. So solve it any way you like. I think it'd be easiest to, let me recopy, 0 equals c1 plus c2. Maybe divide this one by 5. We get 12 equals minus c1 minus 5 c2. And then I could just add the two equations and the c1s are gone. So we get 12 equals negative 4c2, and c2 would be negative 3. And then if we back substitute, probably the easiest one to use, 0 equals c1 plus c2. So 0 equals c1 minus 3, and c1 is positive 3. Okay, so now finally, whoops, I'm sorry. I was writing and I didn't realize you couldn't see that, so give you a second to catch up, or you could pause it. Okay, so then finally we could write our particular solution. I of t is C1, 3, so we're going back up here to the I of t equation, place C1, C2 by what we found. So C1, 3, e to the negative 5t, and then plus C2, which is minus 3, so minus 3 e to the negative 25t. Okay, so we'll look at the last example. And now e of t, instead of being a constant, is a function of t. So we're going to start the same way. That is, write the equation that Li double prime Ri prime plus 1 over c times I is e prime of t. Okay, and always after you write that equation off to the side, note what e of t is. In this case, 540 e to the negative 5t, and find e prime of t. So you always want to do that right away, because your next step is substitution. And we have to substitute in e prime of t. So 540 tags along, derivative e to the negative 5t to the negative 5t times negative 5, so negative 5 times 540, negative 2700 e to the negative 5t. Okay, now my examples, I chose these numbers so things kind of work out pretty. When you do the homework, they're going to get a lot of fractions involved, so not as nice as how mine work out. But when you look at the review sheet, I designed them so they work out pretty as well. Okay, so now we're ready for substitutions. So L is 4, so 4L I double prime plus R120 I prime plus 1 over C 0.00125 times I equals E prime of T. So again, that's the negative 2700 e to the negative 5t. Okay, I don't want to make any careless mistakes, so I'm going to recopy first two terms and just divide 1 over 0.00125, which is 800. And that's times I equaling the negative 2700 e to the negative 5t. And then if we divide everything by 4, because everything is divisible by 4, it makes it a little bit easier. I double prime plus 30I prime and then plus 200I equals, don't forget to divide this guy by 4 as well, so negative 675 e to the negative 5t. Alright, and this is a non-homogeneous second order linear differential equation with constant coefficients. And so in order to solve that, we need to use the method of undetermined coefficients. And the fact that our solution I is going to be composed of two parts, I sub c plus I sub p, where I sub c is the solution to the homogeneous excuse me, and I sub p is the solution to the non-homogeneous. So first off, the solution to the homogeneous. We get the associated homogeneous. Take I double prime plus 30I prime plus 200I, set it equal to 0. Our characteristic equation, R squared plus 30R plus 200 is 0. I promise yours will work out just like my examples, where they're nice and factorable. As we get here, if we use R plus 10, R plus 20, it works. So R is negative 10 and R is negative 20. So then I sub c is equal to, because the roots are real and distinct, c1 e to the negative 10t plus c2 e to the negative 20t. Okay, so we're going to hold on to that, and then we now need to find I sub p. So recall, with the method of undetermined coefficients, we make an educated guess. And our guess is based on the function that's causing it to be non-homogeneous. So I guess we could look down here at the negative 675 e to the negative 5t. So our guess would have to be that I sub p is equal to a e to the negative 5t. And if we compare I sub c and I sub p, remember we had to make sure we don't get any duplications. So there are no duplications. So our guess is going to be valid. So therefore, we'll find a couple derivatives. I sub p prime be negative 5a e to the negative 5t. I sub p double prime is going to be 25a e to the negative 5t. We substitute into the original differential equation. So let's go back up here to the modified version. So we have I double prime, so 25a e to the negative 5t plus 30 I prime, negative 5a e to the negative 5t, and then plus 200 times I was a e to the negative 5t, and that has to equal negative 675 e to the negative 5t. Excuse me. Now we can divide out, well, let's crunch this down. That's negative 150 plus 200 is 50 plus the 25, so 75a e to the negative 5t is negative 675 e to the negative 5t. Can divide out e to the negative 5t, so 75a is negative 675, and then finally dividing by 75, a is negative 9. Okay, so then that means that I sub p is equal to negative 9 e to the negative 5t, because here is our I sub p, and that further means that I sub c, or that the current I is, again, I sub c plus I sub p, and so therefore we'll say that's I sub c, c1 e to the negative 10t plus c2 e to the negative 20t, and then plus I sub p, which was the negative 5 e to the negative 5t. So I'm going to write that as I of t. So essentially just recopying it, really not necessary, but there it is. We're copied. And we're going to have to use the initial conditions to find C1 and C2, which not only requires us to find I prime of t in general, which would be negative 10 C1 e to the negative 10t minus 20 C2 e to the negative 20t, and then plus 45 e to the negative 5t, but it requires us to find I prime of 0. So at this point, we need I prime of 0. So that was the special equation. Recall that we used last time, Li prime of 0 plus Ri of 0 plus 1 over c times q of 0 is equal to e of 0. But note that e of 0 is, okay, if you look at e of t, that's way back up at the top here, 540 e to the negative 5t, e of 0, put a 0 in for t, we get 540. So that's a very important thing to note. And it looks like now we're ready to find I prime of 0. Substitute in, L was 4, I prime of 0, that's the only unknown in here that we're looking for, because everything else is a given. And typically, can't say this is true all the time, but typically the I of 0 and the Q of 0 are zeros, okay? And so you really don't even need to show the substitution. I'm going to do it just to be formal, but note that this is the case. Q of 0 and I of 0 are both zeros. But just to be formal, I'll show 120, but then times 0 is I of 0, plus 1 over c, the point 00125. Q of 0, that's 0 again, equals the E of 0, which, very important, note, it was 540. So therefore we get 4 I prime of 0 is 540. And that means that I prime of 0 is, dividing both sides by 4, 135. Okay, so now for the initial conditions. I of 0 was 0. So we'd have, okay, going back to I of t here. So now we're looking at these two equations for the initial conditions. We'd have 0 equals C1 plus C2 minus 9. And I prime of 0 is 135, as we just found. Gives us 135 equals negative 10 C1 minus 20 C2 plus 45. Okay, and you could solve this system any way that you like. I think what I'm going to do is first just get the C1s and C2s on one side. So I have 9 is equal to C1 plus C2, and then subtracting 45 from both sides, we get 90 equals negative 10 C1 minus 20 C2. Okay, and then I think I'll divide this bottom one by 10. So then we get 9 equals C1 plus C2, and 9 equals negative C1 minus 2 C2. And then if we just add those two equations together, the C1s are eliminated. We get 18 equals negative C2. So C2 is negative 18. And then if we back substitute, I'll use the 9 equals C1 plus C2 equation. 9 would be C1 minus 18, so C1 would be 27. Okay, so finally we go back to I of t, and I of t is, okay, it was C1 e to the negative 10t, so 27 e to the negative 10t plus C2, which is minus 18, e to the negative 20t, and then minus 9 e to the negative 5t. Okay, so that's it. That's the end of the material for exam 3. So check your Blackboard announcements, check your T-Wolves emails. I'll be sending things out in terms of how we're going to assess you for this third exam.